So I'm Carl Moberg. I am the CTO of Avassa Systems. We are a Swedish software company, fairly recently started, founded by a team of industry veterans with kind of a long background in distributed science, distributed systems, actually in academia. And some of the team came together first actually at Ericsson's computer science lab in the 90s. So we've been going at this kind of general problem space for quite some time, and been through a couple of startups along the way, mostly actually focused on building automation and orchestration systems, but always with a software focus. And maybe most recently, and if you guys recognize my face, we worked together at a company called Telia, where we focused on building a kind of solid foundation for programmable multi-vendor networks, that little challenge. And that company got picked up by Cisco in 2014, and we stayed on with that product until we founded Avassa in early 2020. So, of course, much of what we're doing now is obviously based on quite a bit of observations that we've been doing throughout the years. And we've spent quite a bit of time in enterprise networks and enterprise infrastructure, if you like. And there was always something on top of our networking automation solution. And that something was always application-centric. So with Avassa, we decided really early on, and again, with a little bit of careful disconnect from our background, we decided early on to really focus on the applications. So you won't be hearing much about infrastructure management from me today, but you will be hearing excessive amounts of talk about great abstractions and automation and orchestration for the applications themselves. All right. So when we looked at what state-of-the-art automation and orchestration systems for applications looked like, we could clearly see, of course, that the public cloud-centric solutions were ahead, right? So they're obviously built on top of some of the basic assumptions for public cloud infrastructure, for the substrate that is the public cloud. And with our automation and orchestration glasses on, we could clearly see that, of course, a public cloud is built off of many computers, actually a staggering amount of PCs normally, in a few locations, maybe not a single data center like it says on the slide, but in a few locations. Fast and really cheap networking inside of the data center, and tools for automation and orchestration is of course designed for utilization, right? To make compute cheap, if you like. And location, particularly location for specific applications, and particularly on a host level, simply isn't very important in that paradigm, right? And we also heard, of course, that there's a number of reasons why some of the larger enterprises are looking to deploy applications outside of the public cloud paradigm. And we realized that if the distributed edge cloud, which is kind of the somewhat too long term that I'm going to use here, and I'll try to pin down what that is. If the distributed edge cloud is to become a something, it will call for a little bit of a new approach that builds on the cool work already done for the public cloud, but of course with solutions that are more built to purpose for such a distributed environment. And of course, the reasons we heard, the reasons we observed from the enterprises are wide-ranging and of, let's say, different qualities. So we've kind of divided them into three buckets here. One is autonomy and resiliency, meaning that you may not want your vacuum to come to a grinding halt because of your Amazon availability zone has an outage. Privacy and regulations, probably the softest angle to this. And it feels like I'm reading this to people that already know this, but of course, predictable latency and data explosion is for the technical crowd. You could maybe pare that down to short ping times. And we're not taking favorites here. All we're doing is we're observing a number of things. I'm almost thinking of this like a Brownian gas motion that's pushing towards the right side here. And if we think about the distributed edge cloud, of course, that has a set of other definitions to it, or a set of other ways that it's built. And of course, what we're talking about here is when you have fewer computers, maybe just a handful of computers, but in many, many more locations. And when the apps and the data is, of course, distributed across these locations, and less reliable networking, right? If you think about a healthcare provider, or if you think about a retail chain, of course, there's always going to be some planned or unplanned outages for, let's say, the upstream connectivity. So that's what I mean by that. And where location is meaningful, it's actually a first-class citizen in the abstraction. So it actually carries some sort of meaning for the application operations teams. And so that's what we've gone ahead and realized, is that between the public cloud and the distributed edge cloud, there are different definitions of what's good. And when we looked at it, we couldn't really see any solid, useful abstractions for automation and orchestration in the distributed edge cloud, but a lot of things to build off of that obviously came out of the public cloud. And worth pointing out here, before I go a little bit deeper down into the stack, is that we're currently fully focused on managing containerized applications, right? Because that's one of those pivotal technologies that will allow us to build upon a solid foundation of abstractions and automation, right? And the first version that we've built here is useful all the way out to where containers cease to be useful. So I just wanted to point out that we're not a firmware management company. We're still firmly in the general compute domain, right? We don't upgrade video camera firmwares. But as far out as you have a useful container runtime, we think we add value. And obviously, we're not competing with the public cloud paradigm. Again, we're going after a great solution to the distributed domain. And actually, and I'll talk more about that, we think there's a really awesome opportunity here to be more of an augmentation and more of a seamless integration, if you like, with the public cloud, and allow people to really deploy their applications across both in a way that makes sense, of course, both for the applications and for the teams. When we further looked into what kind of challenge this is, right? We started breaking down the space, and we realized that there are obviously two types of tasks that you need to kind of solve for if you want to provide a solution to the right side of the previous slide. One is to kind of manage the distributed runtimes, right? To manage the distributed substrate, the multiplicity of computers in a multiplicity of locations. And what I mean by that, of course, is that if we think about the distributed sites and the constituent host as kind of almost like the raw material or the moving parts, someone needs to make them come alive as an integrated whole, right? So you need to manage the distributed sets of runtimes that you have. So that includes things like resource planning and onboarding of new sites, or extending sites with adding hosts, and of course, decommissioning sites, but also grouping and assigning resources from sites to people that want to use them, or to teams that want to use them. Basically, making sure that all these distributed sites are humming along nicely. And we kind of group this into a role we call the Edge Cloud Manager. And I feel like I'm kind of, I'm walking in a China shop here, because one thing we realized really early on is that this part of the industry has already managed to mangle terminology to the point that we almost have to invent new terms every time, or carefully ask the audience. But we call them Edge Cloud Managers. They have a distinct interest in the actual infrastructure themselves that people will eventually run computer programs on. And the end user on the top left, of course, are the users that are application focused, right? And they are the end users of this kind of system, of course. Well, some people call them application operations teams or DevOps teams, and at some times they are integrated with the actual development team, but they come at this kind of infrastructure with an intense interest in running their computer programs on it. What we observed really early on is that they have had a great couple of years migrating to the cloud. They are spoiled in the most fascinating and awesome way we could ever imagine. They've been gifted the power of the enormousness of the portfolio of the cloud giants at their fingertips. So they're used to, and most of them have either already migrated or are about to migrate both their tooling and the processes to the public cloud paradigm. So we understand really on that if someone wants to build a useful and valuable distributed edge cloud, it needs to meet the expectations of those application teams. And we also see that there's a very interesting mix between teams deploying exclusively for the edge cloud, right? That's what they do. All their applications are running on the edge cloud, but also quite a large set of the users that we work with this far has kind of a split view. Parts of their applications or their application topologies are running in the public cloud, while other constituent parts of their applications are running in the distributed domain. And of course, our mission here is to help them do that in whichever configuration they need, right? So really lowering the barrier of entry for either running everything exclusively on the edge or in a combined fashion. And when we looked at this, of course, we realized that, of course, maybe the most basic part is something people feel are somewhat solved. So basically just distributing the computer programs and running them on multiple locations is something people can do. And what we've seen, like a first wave of edge cloud computing people have done. But when we look deeper into how these teams function and what kind of course, processes and tools they have in place, we realized that, for example, both monitoring and observability, which I heard someone call hipster monitoring, actually takes a different form when you run your application. Instead of running your application consisting of maybe 20 containers in 2 places, you run your application that may consist of 2 to 3 containers, but you run it in 256 or 1024 places. Monitoring and observability transforms into something very, very different. Actually, you have to kind of rethink the way you do that. You have to rethink the definition of my application is running fine, thank you very much, right? It looks different between those two. And autonomy, which is a huge term, right? Another term that is stretched very far. The way I interpret it and the way I talk about it is that if we run things towards the edge of an infrastructure and you lose connectivity to that infrastructure, what can we do to protect the applications from falling over immediately? What is it that the local infrastructure can provide to at least allow the applications to degrade in a more controlled fashion? And you have things like security, which turns out to be, again, a whole nother ballpark when the edge infrastructure is located in a public location, like on a light pole. So someone can climb the light pole and steal the PC and may want to exfiltrate data. How do you actually secure that data? And then you have consumption. Of course, we have users that want to charge for access to their edge cloud. And you have tenancy, right? You want to be able to have applications stemming from teams that may even be adverse. How do you actually provide deep tenancy in a distributed fashion? So when we realized that this is actually a pretty massive shift, and again, calls for what we believe to be a somewhat different approach, that's what made us excited enough to kickstart Avassa. So that's how we got started in this problem domain. So we've built it, of course. We've built 2 pieces of software. We built a centralized component, and I will talk a little bit more in detail about this in a couple of minutes. That's called Control Tower. And the Control Tower is, of course, the single point of entry for both humans and machines that want to, again, manage either the infrastructure or, for that matter, cares deeply about applications running on that distributed infrastructure. And the second component is something we call the Edge Enforcer, which is an agent-like piece of software that you actually install on the constituent hosts in the constituent sites of your distributed infrastructure. And between the 2 of them, of course, the point here is that they then deliver on the challenges in an integrated fashion, such that, again, the barrier of entry for deploying applications, either directly to or migrated from the public cloud, should be significantly lowered. And if we look at these constituent parts one by one, of course, the left one is probably the Avassa Control Tower, I should say, is probably the easiest to conceptualize. Again, it is what anyone or any kind of automation system interacts with. And we already have users spanning all the way from wanting to use this as the single point of entry for users, actually using a web UI, to people that don't want to leave, for example, their AWS experience or GCP or Azure experience, but want to integrate their processes and tools with the APIs that we provide. And of course, it has what I now call the holy trio of interfaces, which is a command line interface, a set of APIs and a web UI, and of course, driven off of a infrastructure as code approach and a model-driven backend. For those who know a little bit about our background with TLF, know that we are pretty hooked on the idea of model-driven and eventually convergent systems. And the Avassa Edge Enforcer is probably, though, where we've put the most of our brain power. That is the manifestation of what's actually a little hard or a little challenging in this domain. So as I mentioned, it's a piece of software. It's actually installed as a container. So it assumes a container runtime with some elevated privileges, which means that it takes over to the extent that you allow it the scheduling and the management of the container lifecycle on the local hosts. And it also comes actually with an integrated super lightweight cluster management. It uses the Raft algorithm, like other known solutions in this domain, for sites that actually has more than one host. And conceptually, you can think of the Edge Enforcer having two roles or two phases in this system, or two things that it provides. First of all, it's an integral part, of course, of the Avassa platform infrastructure. So for example, when you start it up, it calls home, it reports the available resources, it reports whatever other software is running locally. And it sets up the configuration needed, right? It's a zero touch and zero trust solution for onboarding new sites. So that's really important, of course, to make this a low barrier and cheap, low toil kind of solution. And of course, to take out the per site or per host configuration from the equation here, right? Because again, we're looking at customers that have tens or hundreds and soon to become thousands of sites. So any singular manual step that they have to make in this kind of setting is, of course, going to be a big hindrance. The second aspect of the Edge Enforcer, which I find to be very interesting, comes out of the interaction that we've had with users. Turns out that the users expect quite a bit from the infrastructure these days. The application teams and the developers expect lots of things from the infrastructure itself, which doesn't necessarily come with, let's say, piecemeal open source based solutions in this domain, right? So we have three examples on this slide. First of all, if you want to be somewhat resilient, you need to have a distributed registry for your container images, meaning that you have to be able to do, for example, a cluster failover or an upgrade, even though your upstream connectivity is down, which means that you actually have to come up with a clever way of distributing the containers such that they are available in the sites where they're running, right? You can't distribute all of the containers to all of the sites, but you want to make sure you have the correct containers at the correct sites at the correct time. So the Edge Enforcer actually implements a distributed container registry that is tenant specific or multi-tenant, and has its own security subsystem and policy for access to its APIs. The second thing we learned really early on was that, of course, you expect as an application developer person to have some sort of event streaming or log event streaming. You can think of Kafka or a Pulsar. That becomes a really interesting challenge if you want to build a multi-tenant system on thousands of locations and you have somewhat limited resources. Because, of course, many of those solutions aren't built for that. They are built for the left side where you have ample amounts of resources. And recognizing that, of course, we implemented a publish subscriber log event log streaming interface in the local APIs of the Edge Enforcer with service discovery. So you get the same kind of service that you get from, let's say, again, a Kafka or a Pulsar in a centralized fashion, but it's multi-tenant and it's policy driven, and it's, of course, no configuration for it. And it also turns out that some of the communication patterns or the log event patterns that is required for the Edge, of course, is not around in the open source dominant log event streaming solutions, like, for example, leaf-to-leaf communication at the Edge, or for that matter, again, multi-tenant and multi-topic solutions. While most of our users today use this as a way of offloading data from the distributed domain to the northbound interface off of the control tower, we also see quite a bit of interest, again, in doing things like site-to-site communication and state sharing and things like that. So that turned out to be a very, very interesting challenge to implement. Second thing, which came as a little bit of a surprise to me, is that people are now very used to what seems to be broadly called secrets management. You can think of a CyberArk or a HashiCorp Vault. And of course, that too is something that needs to be available through local API, service discoverable. It needs to be multi-tenant. It needs to be obviously secure. It needs to be policy driven. So we've actually implemented that as well in the Edge Enforcer. So you get a secrets management API locally available to the applications. And that turned out to be a very interesting thing. For example, if you have, again, let's say 1,024 Edge sites, which are running some sort of a web front end, you are probably interested in rotating your certificates, which can be a little bit of a challenge, again, if you have many, many sites. by using this, you can actually then have a single operation on the northbound interface, and using this distributed secrets management system, you rotate the certificates across that whole set of sites. And the same thing goes for application credentials, and it goes for a whole slew of things around about how do you lifecycle in a secure fashion sensitive material. And of course, one of the things that are unique to this problem space is something we call the application deployment specifications, which is, it's just a name of our format. And what's unique is that this is a way for the application teams to explain to the system that these are the criteria under which I want my application to be started. And an obvious criteria in the edge domain can be geographical. Right? I want to deploy this application in all data centers or in all sites inside of a particular geographical boundary. But it can also be things like I can only deploy this application if one of the hosts, because many of these sites are heterogeneous in terms of hardware, if one of the hosts at the site has a TPM module or maybe Intel Enclave computing support. So the deployment specifications is a way of telling the system, here's an application, here are the constituent containers, and here are directions that needs to match, or criteria that needs to match the sites where I want to run this application. And that opens up for a lot of interesting improvements, we believe, in the abstractions here, meaning that if you fire up a new host in an existing site, this will be reevaluated. If you fire up a whole new site that actually matches a service's criteria, we will make sure that it eventually gets started to at that. If your site actually stops matching a particular service, we will make sure to prune the services or remove the containers that have that kind of criteria to it. So you can think of it as a filtering mechanism that is constantly reevaluated to make sure that the applications are running in the appropriate sites, which we think is something that will eventually have to emerge. And maybe this is something we can come together as an industry and talk about how that should be expressed in some sort of a standardized fashion. I would love to hear any feedback or questions that you guys may have on what I just presented.
Yeah, so Carl, I would like to fire up with a question right now. So I'm Max Mortillaro, I'm co-owner at Tech Unplugged and analyst at GigaOM. My question is about the deployment model. So you have this software as Avassa solution. How do you install that? Does it run as a virtual machine? Do you deploy it on bare metal hosts? I think you touched a bit on that, but if you can maybe just clarify once more, will be helpful.
Thank you. Excellent question. So the control tower can actually be consumed in two ways, right? One is as a service. So this is actually something we still have as a pilot program. So it's by invitation only. It's something that we are eventually going to launch as the Avassa cloud platform. So for people that have the appetite to, they will actually consume the control tower as a service, of course, fully managed by us. And the second way, the second setup here is, of course, we have users that aren't ready for or doesn't want to consume orchestration as a service. With our background in automation and orchestration, we recognize that's probably going to hold true for a little further. And for those customers, we have an addition where they can deploy the control tower on-prem, meaning in their own data center. And of course, this is something we manage actually through the control tower. So it's a self-managed system, if you like. It actually, in a little bit of a Munchausen way, manages its own applications, all packaged as containers, of course. So easily deployable on the well-known platforms.
Yeah, that was very helpful. But that means in that case that you do not take care of anything. Maybe I think you mentioned that you do not take care of anything infrastructure related, right? You expect people to come in with their own infrastructure, they install Avassa, and then they start managing their distributed edge cloud.
Exactly. So a typical like end-to-end demo of this would be to say, look, here is a set of sites with one or more hosts in them that has your flavor of Linux and a container runtime that you like. Here's what you do to actually install the edge enforcer and show how that would call home, and then see how that actually immediately makes that site or those hosts available for assignment to tenants or for use by the root user to deploy applications on them. And of course, this is something we're looking forward to demoing further down the line here, maybe even at a tech field day.
This is Adam Post here. I'm an infrastructure architect. You talked about the advantages of deploying a centralized model versus decentralized. One of the advantages of the public cloud, right, is that we have software-defined storage, software-defined networking constructs available to us to facilitate the normal operation and the publishing of our application. Now, when you move to the edge, you may not have some of those constructs available to you. So you mentioned as part of the life cycle of publishing an application, orchestrating all of that. How do you handle some of the storage, persistent storage needs, and orchestrating the networking elements needed to publish your application at the edge where those types of functions may not be as available to you?
That is a really cool question. And let me split it into two, because that's another solid 10 minutes otherwise. The first one I can talk about is networking. What's really awesome about thinking about that in terms of edge locations, where again, I give myself the opportunity to assume, not data center like amounts of resources, but rather, let's say, at a maximum, maybe a full rack, that kind of thing, right? And there are certain side effects to that. For example, many of our users doesn't have, for example, horizontal elasticity as a primary and important feature. They over-provision the hardware and they make sure that they build fairly tight applications because they recognize that, maybe for space reasons or cost reasons or other reasons, it is non-trivial to expand the amount of compute, okay? This means that it's a great opportunity to be very, very opinionated on networking. We can decide on a very finite set of constructs between constituent containers inside of what we call an application, and between applications inside of a tenant, and if needed, between tenants. So that takes out so much complexity that we understand and appreciate is really important for, again, for public cloud, super elastic environments, and allows us to assume and have strong opinions about networking constructs this far. And for now, and we'll see how far this holds, we've been able to actually, if you like, infer the networking constructs from the application specifications, rather than actually call out and expose network specifics in the specifications that you do for your applications. We'll see how far that goes, but for now, that seems to resonate really well with the customers. We've managed to pare down the amount of, let's say, input you need for an application from what they're used to, which is Kubernetes-like normally, into something that is really focused on the application, and we're allowed, again, to have opinions about, for example, which networking technologies to use between the applications and between applications inside of a tenant, and if needed, through the ingress and between tenants. And the solution we have today is heavily focused on VXLAN, intrasite, and we use WireGuard to protect the data, both going in and out of the container runtime environments. And the second part is, you asked, was about storage. That one, to me, and this is reflected in our solution as well, is still not really solved. So that's where we have a more of a, if you like, a more neutral posture, and it comes down to container volumes. Nothing more, nothing less. We are working together with more, let's say, advanced edge storage solution providers, but they are their own, so to speak. They're outside the realm of what we provide, or what's available, I guess, in kind of an open source fashion. So that's actually something that we see us taking on a little further down the line, maybe as part of our own solution or as a tighter integration with whomever comes out on top and gets the most love for the distributed storage.
Hi, Carl, I'm Arthur Baig. I'm an enterprise solutions architect. Firstly, let me say that I'm glad that you mentioned that apart from available as a service option that's coming for the control tower side of things, there is separate deployments as well, because you can imagine that a lot of organizations want to keep their environment tightly in control, not sharing with anyone, and tinkering with it as well. So is it fair to say that, control tower is the brains of the operation, is supposed to be completely central to wherever they want it to be, like on-prem or in a cloud environment? So if that's the case, and then you have the different sites distributed. Obviously, everything is running autonomously in that environment using the edge enforcers. There has to be communication at regular intervals, probably all the time. And when there's a network break and all those kinds of things. So how often and how resilient that data synchronization is, and how do we ensure that it's always secure, but also up to date, kept up to date, for example, as soon as, say, connectivity is restored? What's the mechanism doing that?
Sure. Okay, so there are, I mean, in my mind, there's two important things here. The first one is setting up, actually, let's call it call home, or maybe resource registration, right? We know that there's going to be at least one layer of NAT between the control tower and the edge enforcers. So it's actually initialized from the edge enforcer. So real brief, the two types of input you have for the edge enforcer is a domain name for the control tower and a certificate to make sure that you're actually connecting to the right control tower. So we use SSH for that. So that's how you actually set it up. And then we switch over to a TLS-based communication between them. And what happens then is that there are many things here that I haven't really had time to touch on, but based off of the same system that we use for event logging, we have our own communication patterns going between the control tower and the edge enforcers. And it's both a edge enforcer to the control tower and control tower to the edge enforcer. So it goes both ways. But at the heart of it, it is actually a means of synchronizing what could be thought of as configuration. I have a very specific view of what configuration is. But you could think of, for example, when you're deploying an application or a service, what we call an application, which is a set of containers, and it is up to the control tower to figure out, of course, which sites match these criteria that the user has for this, right? So that's communication with each site. And the result of that is, of course, saved in the control tower. And the configuration for that service is actually also saved at the edge enforcer. So the edge enforcer realizes that this is the end configuration that I'm going for. And it includes things like start up this container, connect these two containers with this kind of networking, and open up an ingress. So that means that there's a local, if you like, cache of configuration, and there's a centralized view of where things are running. So let's say you lose connectivity, right? And what happens then, and that also kind of ties into what we talked about with graceful degradation of applications. The applications up to a certain point will still be able to write and to some extent read things in the logging infrastructure and in the secrets manager. And the edge enforcer itself will still have its configuration. So it will hum along nicely. There's a couple of things you can configure, of course. We have customers that want this to work for months. And for that, you will just have to trust that it's reasonable to keep going on that configuration. We have other users that say, well, if you haven't heard anything from this control tower for a couple of days, then maybe that's a problem, and maybe do something about it. And what happens when that connectivity comes back up is that the edge enforcer will find that it suddenly can reach the control tower, and will obviously ask, have anything changed with the configuration that I have since I last asked? So it becomes a configuration merge, almost construct, if you like. And I don't want to downplay it too much, because that can become really, really interesting. Because of course there's a lot, you could think of an environment where you have a number of newly deployed applications from the control tower when you have one site down, right? And most of our users would say, well, if it's only one out of 1,024, that's not a catastrophic thing. So buffer, right? But then they may actually remove that service or change it, right? So it comes down to having a solid and centralized, in this case, source of truth, and a pretty flexible and powerful means of merging that during disconnections, or when disconnected sites come up again, in a way that makes sense to the edge enforcer, because of course, at the end of the day, what that edge enforcer needs to do is to figure out what is it that I need to do now in order to fulfill this new configuration that comes in. And that can be actually quite a complex, kind of a complex task, if you like. Am I going in the right direction, Arthur? Am I responding to your question?
Absolutely, yeah. I mean,
Awesome.
because obviously there's only a limited amount of detail that we can go in right now, but I think that explains the mechanism and the process behind it at a higher level quite well. If I may, just quick, another question about this and a control tower in both its flavors, for example. And I just wanted to clarify in my head when we talk about the multi-tenancy side of things. Now, if a customer has, or whoever is using it, have their own control tower, then probably multi-tenancy means different environments maybe on it. But as a service, for example, once that's in place and people subscribe to it, does it mean different organizations but kept isolated from each other, but serving different organizations? Or does it mean just the multiple sites that an organization might have, but everyone gets their own control tower?
So you can think of a control tower instance as belonging to one edge cloud manager. So the organization or the people that owns the distributed infrastructure is also, let's say, the root user of the control tower. And of course, they can use it themselves, but we also have a number of users that says, well, I want to have application tenants. So I have different application organizations, internal or external, that I want to assign certain subsets of this edge, right? And if you go all the way to our communication service provider or ISP kind of customers, of course, they even have a commercial relationship between the edge cloud manager, the owner of the distributed cloud, which are them, and hopefully in their case, hopefully enterprises that wants an instance or wants a tenant inside of their edge cloud, right? So you could think of an edge cloud manager owning a control tower and can then optionally actually create tenants and assign them subsets of resources. And each tenant will have a very isolated, so this is not a role-based access control or anything like that. It's a deeply isolated slices with their own domain names, own APIs, own UIs, and all that kind of stuff, right? Because that part of our user base is actually quite interesting and quite fast moving, the people that need tenancy. And maybe also, the reverse to that is that they have a hard time finding ways of building such functions into, let's say, an open source based system. It's really hard to create a multi-tenant system for this kind of environment on top of 3 or 4 or maybe 5 open source components, right? Because they simply weren't built for that kind of deep integration and consistency of the idea of tenancy between them. So it's a very important kind of feature for a particular type of user that we have.
Hey, Carl. I'm Mike Stump. I'm a consulting engineer and a analyst. And I just have a question or two about, I guess, kind of the operational side of this solution. Specifically when it comes to tracking any changes or updates that might be required for those edge enforcers. And I guess more specifically, does the control tower have any mechanism to report back on the versions of those agents? And does it have the ability to update them? Let's say that you discover a security vulnerability, you need to make an urgent change. Could you kind of walk us through what that would look like?
Sure, for sure. And I tend to think about, of course, the compute hosts in the distributed sites in layers, right? That's not a game changer. And of course, you have your hardware, be that physical or virtual. We do have a lot of users that actually build hypervisor-based clusters, and they run, operating system instances with container runtimes, and then they put our stuff on top of that. So be that physical or virtual hardware, and you have the operating system, and you have the container runtime. That's actually not something that we currently manage. The opinions about how to do that are, in our experience this far, very much in the hands of the IT organization or whatever you want to call the organization that runs the sites, right? There doesn't seem to be a very common understanding around that enough that they would ask a vendor like us to do it. Another way of saying it maybe is that they have that down pat, or at least that's what they feel like they do.
Sure, but
However,
I guess I'm thinking specifically to the edge enforcer agent itself, right? So I agree with you that there's that stacked layer, and you should let the service providers do what they do best. But when it comes to this software, that's what I'm curious about.
Yes. So the edge enforcers are fully managed by the control tower. So all versioning, all life cycling, all of that is actually managed through the control tower, and with a very, very small amount of let's call it surface for the users. It's a very, very simple set of actions to upgrade, at quite a staggering scale, if you like, the versions of the edge enforcers themselves. This is one of the things that we found to be awesome with container technology, is that it really allows that which used to be horrible and very specific to Linux distribution, for example, to be way less horrible and more stable. So it's something that we definitely have as an integral part of the lifecycle of the system itself, and it actually goes for the control tower constituent components itself. Awesome. Thank you very much for your questions, guys. I hope that made sense. Certainly was interesting to explain this to you. Hopefully I made sense as well.